So when we look at using plants, it's part of a bioregenerative system rather than a chemical or mechanical, purely mechanical system. It's bioregenerative. It's part of closed loop life support, which means that you're reducing your reliance on Earth supplies. And NASA lead scientist Ray Wheeler has asserted that greenhouses provide a more autonomous approach to long-term exploration for the moon, Mars, and beyond. So we are truly looking at growing beyond Earth. To grow plants in space, currently on the International Space Station, they use the veggie system, which is a low-cost, hydroponically based agricultural system. The LED lights provide that balance of red and blue light. They grow in little specially designed seed pillows, and astronauts have successfully eaten lettuce that has been grown on veggie. There's a lot of research that has to go into growing plants this way in microgravity because water does not operate as in the way that it does here on Earth. As that fluid and it bubbles up, it can coat the roots of the plant and contribute to root rot. So we really have to focus on how nutrients are delivered and how water is delivered to the plants in such systems. And NASA continues to work on that project to grow a variety of plants and even algae. We also have controlled environment agricultural center or hydroponic greenhouses. So these are containers where they've looked at increasing the bioregenerative support system, in which you have more integrated systems with water and biomass and recycling the air, for instance, recycling the water, recycling wastewater and waste as well. And there's been continued research on how we might be able to do that on Mars. Now, one of the challenges we would have is we went on Mars, would we have to be careful of the ionizing radiation, and that can also affect the DNA of humans, and it could cause damage in the plants. So it's very unlikely that we would have above ground greenhouses that are open to gain sunlight. You've got limited sun ability anyway at the atmosphere of Mars, but it's definitely an option to increase the amount of space on in situ on the surface compared to only using a veggie system. And then there's the question of Martian gardens and in situ resource utilization. So Martian regolith could become fertile enough to grow crops, but it will require significant intervention for that to happen. You may have seen the popular movie, The Martian, in which he grew potatoes. But there are major challenges to growing plants in that regolith. Particularly, you need to address the nitrogen levels, the particle size, the density, and the pH. And there are perchlorates in the soils, which are salts that would also have to be washed out, as they are toxic to humans and to most plants as well. So the challenge is that there are no Martian, or there are no, that we know of, no Martian microorganisms in the soil that would benefit plant growth. The toxic perchlorates, the clay size of the particles would suffocate the roots. That very fine, powdery, it's like floury texture of the soil, as we've talked about one of the other lessons. There's rapid water loss, and there's nutrient deficiency. We've talked about in another session as well, soil degradation, issues with soil salinization, drought, questions of fertilizers, unknowns about GMOs. Those are many of the same issues that we face on Earth that we would face on Mars. And one of the movies that I love to show my students for AP Environmental Science is The Biggest Little Farm. And in that movie, they talk about turning this dry, dead dirt horse ranch into a self-sustaining farm on 213 acres. So production at that scale would take significantly longer and obviously require enclosures for adequate temperature, pressure, gas exchange, and radiation protection. So it's probably not likely we're going to see any 200 acre greenhouses on Mars. So we're going to have to figure out how to farm in a different way. We can see on Earth the way small farms have increased significant production. They use hydroponics, aquaponics, permaculture, biointensive techniques, as well as other sustainable and organic methods to produce high quality and high quantity of plants for consumption. And so some of these small farm techniques on Earth can prepare us for Martian farming, because even on a little less than half an acre, we know that a plant-based diet can produce about 2,300 calories per day for an individual. So how can we maximize that?